when we do these subatomic particle questions, what we have to do is we have to look at what we know and then try to figure out from that the little bits and pieces of information that we don't. So first, let's look at the isotope. The isotope here is gold 197. Here, this 197 is the mass number, and then the 79 is the atomic number. And as a little bit of review, mass number is the same thing as protons plus neutrons. And the atomic number is the same as the number of protons. So let's go ahead and look over here. What don't we know? First thing that we're asked to find is the mass number. Well, the mass number is just what's in the top left of the nuclear notation, which is 197, which is the protons plus the neutrons. Next, we're asked to find the number of protons, which is the same thing as the atomic number. So let's go ahead and write that down. Now, because we know that the mass number is protons plus neutrons, and the number of protons is 79, therefore 197 minus 79 will be our number of neutrons. Put those in, you get 118 neutrons. Now, to find the number of electrons, we have to remember that in a neutral atom, where the charge is 0, the number of protons plus the number of electrons, or I should say the number of protons equals the number of electrons. It's because protons all have a +1 charge, electrons all have a -1 charge. Therefore, for the charge to be 0, these two have to equal out. So therefore, if you have 79 protons, you're going to have 79 electrons to make it a charge of 0. Next one, carbon-14. Well, let's just go ahead and write our nuclear notation for carbon-14. We know it's a C, and we know 14 is here. And looking at the periodic table, we know that carbon is the 6th element. It has 6 protons, so we'll put a 6 there. The atomic number is just the same as number of protons, that's 6. Mass number, same thing as the number in our isotope name, protons plus neutrons, which is 14. And so now we can go ahead and fill out the rest of this. Protons is the same as the atomic number. Neutrons is the mass number minus the atomic number, or the mass number minus number of protons, which is therefore 8. 14 minus 6 is 8. And then the last thing we're trying to figure out here, it doesn't give us a charge, in which case let's just assume it's 0. That's a safe assumption, unless we're told otherwise. And so therefore, as we went over before, if you have 6 protons, for the charge to be 0, you need 6 electrons. Okay, now this one looks a little bit more difficult. What we have to realize is the atomic number is what determines which element it is. So if you look at your periodic table, element number 19 is potassium, K. And so we know potassium is the 19th element, therefore we put 19 down here. And the mass number is 39, therefore we put a 39 up here on top. So therefore our isotope name is potassium 39. Potassium 39. And the number of protons is the same as the atomic number. Neutrons is going to be mass number minus protons. 39 minus 19 is 20. And now here we're given a number of electrons, which is different from the number of protons. Therefore, it's going to be an ion. And because electrons have a negative charge, protons have a positive charge, and therefore our charge overall, because we have more protons, is going to be positive. So 19 minus 18, that ends up giving you a +1 charge. The last isotope that we're given here is silicon 29. So we have silicon, 29 mass number, 14 is the atomic number. So let's write that out here. Silicon, and that would be 29. So given the atomic number here, what we're given that right here, we can just put that same thing in here. 14 is the atomic number. 29 we're given as the mass number. Now, filling out the rest, by now we should see that 14 is the number of protons, because it's element number 14. Neutrons is our mass number minus protons, 29 minus 14, which gives us 15. And it doesn't give us a charge, so we'll just go ahead and say 14 electrons to make it neutral. And therefore the charge in this case would be 0.